of the definite integral. Okay, here is one property. The integral from a to b from f of x dx can be replaced by the opposite of the integral from b to a, reversing the limits of integration from f of x dx. Sometimes we do that. Sometimes we apply this property. Property number 2. When we integrate from a to b a constant, we can take the constant in front, and then I have the integral from 1. There must be something there. So from a to b dx. We already know how to integrate or how to determine a definite integral. What function prime is 1? Well, it's x from a to b. So all I have to do is just plug in, constant stays outside, I plug in b, and I subtract when I plug in a. Stop me if you have questions. Property 3. The integral from a to a from f of x dx is 0. There is no interval. So if I have the integral from a to a, there is no integral. There is no interval. So the integral is 0. Number 4. The integral from a to c from f of x dx is the same with the integral from a to b from f of x dx plus the integral from b to c from f of x dx. How does this look and what does it mean? Okay, so let's take a look at a little graph here to see what it means. So imagine that we want to determine the area under this graph. And I have here A, I have here B, and I have here C. So obviously this is the area in question, the integral from A to C from f of x dx. But it's the same with, if I break it anywhere, this is not in the middle, just anywhere you want, is this area, which is the integral from a to b from f of x dx, plus this area, which is the integral from b to c from f of x dx. So in other words, I can break it up anywhere. All these assume that f of x is continuous. All these properties assume that the function is continuous on the given interval. I already used this property, but let's write it again. So the integral from a to b from a constant times the function multiplication dx. Of course, this is the constant times the integral from a to b from f of x dx. I can also apply the definite integral to any difference or sum of functions. The integral from a to b from f of x plus or minus g of x dx. Of course, it's the same like with limits. So this will be the integral from a to b from f of x dx plus or minus depending on what I have. If I have plus, I have plus. If I have minus, minus. From a to b from g of x dx.
Can you slow down just the teens just a little bit so we have time to finish writing all that?
Yes, sure. Any questions? Any questions? Are we okay? So far, so good? Anyone?
Yep.
Okay, here's another property for odd functions. Not only odd functions, and there is another condition here, and symmetric interval. Odd functions and symmetric interval. So here's an odd function. We know this very well. X cubed. Here's x cubed. And let's suppose we have an integral between negative a and positive a. Symmetric interval, like negative 2, 2, negative 5, 5. So the integral from negative a to a from f of x dx, if the function is odd, and of course the interval is symmetric, what do you think this will equal to?
Zero.
Thank you. Because this is a negative area and this is a positive area, and since the function is odd, which means symmetric with respect to the origin, the areas are identical, they will be just opposites in sign. Very good, awesome. Now, also let's look at what happens with an even function on a symmetric interval. So still on the 7, let's look at an even. Here's a graph of an even function. We know it very, very well. Let's suppose again we have a symmetric interval, negative a to a. And we want to determine the integral from negative a to a. When the function is even. What do you think?
Yes.
2, the integral from 0 to a from f of x dx. So why would we even go through this change? Because this is much easier to evaluate. When I have 0 at the lower limit or 0 at the upper limit, it doesn't matter. When either one is 0, it's always easier to evaluate. Any questions? Any questions? Okay, I think I'm on property 8. If a function is greater than or equal to 0, its integral from a to, on the interval, of course, a comma b, the integral from f of x dx will definitely be greater than or equal to 0. So if the function is positive, it is guaranteed that the area will be positive. Okay, property number 9. So let's suppose now that we have the following graph. I have a function g of x, and above it somewhere I have a function f of x, and of course we are again talking about the interval a comma b. So can I say that on a comma b, on a comma b, I can definitely say that f of x is greater than or equal to g of x according to the graph. Would you agree?
Yes.
Then you will agree that the area under G must be what?
Also greater.
Of course. The area under F must be, so if F is greater than G, the area under G has to be greater than the area under G, of course. And for now, one more property. for definite integrals. Let's suppose now I have this scenario. And no, it's not squeezed between anything, but this is lowercase m, and this is uppercase M. And let's suppose I have a function that does this between a and b. And this is f of x. Now question, first of all, can I write that on a comma b, I can say that f of x has a lower bound of lowercase m, a constant, a number, any number you want, and an uppercase M, lower bound, upper bound. I don't care about outside, but on the interval a comma b, can I say that?
Yes.
Perfect. So then I can say this as well. Which makes sense, it's based on the previous property. So this area is the smallest. This area is the next in line. And definitely, this one is the largest. So if I have the original relationship between the function and these two numbers, then I have to have this relationship between the given integrals. Any questions so far before we choose some problems to work on? Let me know. Okay, I would like us to choose a function for which we cannot determine. Just a quick refresher. Let's say something like the integral from 0 to 8 sine the square root of x dx. I cannot determine this. I cannot find that, so that I can plug in 0 to 8 and give you the exact answer. So what does this integral say? It says find the area under the graph of sine the square root of x between 0 and 8. I cannot find this. Potentially a computer algebra system or computer software like Maple or Mathematica eventually could give us an answer. But we cannot determine this algebraically, or if you want, by hand. So
because it's the inverse of the chain rule, or like about it, it's difficult.
No, we don't have a method of determining this at this point. At this point, it could be possible maybe with integration by parts, but at this point we do not have an algebraic method so far in Calc 1.
Okay.
So I still would like to estimate this. I'm not going to get a perfect answer. I'm not going to get the exact answer, but I still would like to estimate it. And the problem says use the midpoint rule with a given value of n to approximate the integral. Round the answer to 4 decimal places. And they give us n equals 4. So they want us to use 4 subintervals to approximate this integral, because we cannot determine the most general antiderivative. I cannot tell you which function prime is sine the square root of x. But we can still get a number. It will be an approximation. It will not be exact, but still I'm happy with at least determining a number. Okay, so if you remember, we divide the interval between 0 and 8 in 4 subintervals. and this is 2, 4, and 6. The midpoint will be at 1, the midpoint will be at 3, the midpoint will be at 5, and the midpoint will be at 7. So then the integral from 0 to 8 from sine the square root of x dx will be approximately base times height, sine of 1, the square root of 1, plus base times height, sine the square root of 3, plus base times height, sine the square root of 5, etc., etc. Since the base is the same, I'm going to pull it out, and I'm going to write sine the square root of 1 radian plus sine the square root of 3 radians plus sine the square root of 5 and plus sine the square root of 7. We're gonna get the calculator. So here is what I like to do. I go to stat and edit. Eliminate or clear whatever you have in there. And what I want to plug in is 1, 3, 5, and 7. That's all I need. 1, 3, 5, and 7. Once I have this, I will go to the top of list L2, and I will tell L2 what to do with L1. It will have to do 2 multiplied by, there is no need for multiplication, but let's put the multiplication symbol. List second and list L1. Sorry. I want sine first. Sine, parentheses, the square root of list L1. And close the outside parenthesis. So what will the calculator do is this. It will multiply 2 by sine 1 and give the answer here. Then we'll multiply 2 by sine the square root of 3 and put the answer here. And so on and so forth. And when I press enter, I'll get all 4 answers. And now I want the calculator to add up these numbers. And I go to stat, and I want to calculate one variable stats, not on list L1, but I want list L2. And it will calculate and will give me the sum. And here is the notation. So the sum of x is 6.1820 blah, blah, blah. So this is approximately 6.182037199. Of course, I don't need that. They only want 4 decimal places. So we will always have a way of approximating if we cannot determine the exact integral. We will always have a way with the midpoint, leftmost point, rightmost point, and you choose or you are given the number of subintervals. The reason I'm using from stats, one variable stats, is because it's easier for me to add them up. I'm not going to add them up by hand.
Can you repeat that last calculator step one more time?
Yes. So you go to stats and you edit. So you have the variable x. This is the only thing that changes from one to the other. So it's 1, 3, 5, 7. And then at the very top, you're going to put exactly what this will do. 2 multiplied by sine of the square root for list L1. Once you have that, you want to add them up. But I'm not going to use the second calculator and copy what it's here because it's insane to do that. So go to stats, go to calculations, and choose one variable stats, but make sure that it's list L2 if you have this product, 2 times this, 2 times this, 2 times this, 2 times this, in list L2. That's where I have them. And then when I click on calculate, if you have this kind of calculator, but if you even don't, it's still, you press on enter. The first one is the mean, which you do not need. We need the second one, which is the summation notation x in list L2. And you get this, and since the problem is asking us to, you don't need anything else. You don't need the standard deviation, the first quartile, the median, the third quartile, and so on and so forth. You don't need any of that. You only need the sum. And he calculates the sum for you. Is that okay?